All right. Good morning, Hacksters. It is Tuesday again, and that means it is another Hackster Cafe. Today we have Whitney Knitter, an awesome human. We've met in person a couple times, but it has
Yes,
been a while. And you're going to
it
talk
has
to us
been. It was
about,
right before the pandemic that we last saw each other.
yeah, one of those last few events. Um, but anyway, we're here today mostly to talk about the migration from Spartan to Spartan-7, but
Yeah.
there's also a lot of interesting backstory around you personally, specifically with Xilinx products. But yeah, I'd love to go into that a little bit. So Whitney, good morning.
Good morning. Or well,
Would you like to tell us?
afternoon. Yeah, because I'm in New York
Oh,
City
yeah.
actually.
Well then, good afternoon and whatever time of day it is for you around the world. Hello. And
Yes.
yeah, would you like to tell us a little bit about yourself and what you're going to talk about today?
Um, I think the kind of little too long don't read on me specifically is I I went to school I have my master's degree in electrical engineering, and then my undergrad is in computer and electrical engineering. It's like a dual degree. Um, and I always enjoyed kind of the more robotics and embedded side of things. And my first job out of college, it was in 2014, and it was right when Xilinx switched from ISE to Vivado, which we'll go into more later.
Mm.
And I was the new person that was handed here. Let's figure out this new tool for the rest of us to use. That's kind of what started the blog. Is I just didn't have enough time during the day at the office to just fulfill all of my tasks and all my different projects. And so I would go home at night and just kind of play with Vivado and see what random button presses would do / break. And as I would start to figure out what the right sequence of events to press all these buttons, I needed a way to access it at work. And so I just started up a little website builder, and I'd write down all the little button presses that to me weren't obvious as a totally new user fresh out of college, but because I think a lot of the documentation is written by the developers that live and breathe it. So sometimes some of those weird little like menu options that are
Mm.
buried in a right click, like you don't even think about that when you're too close to the software, but someone that's totally new is like, oh man, I really needed someone to explicitly tell me where that was.
Yeah.
So I started making it for myself, and it was solely just so I could at work pull up my own blog and be like, okay, this is how I figured this out at home. Um, and I think just on a whim, I shared it on Twitter at some point, and that's Hackster. Somebody on the Hackster Twitter actually saw it, and then the rest is history.
Wow, love it. I wonder who that was. It was probably, depending on what it was, it's
It
probably
Artie was
Artie.
the first one that reached out to me via email.
Definitely Artie.
Um, yeah.
Cool. So you mentioned that your company was switching from ISE to Vivado. Had you ever used ISE before?
I've used it in the context that I had a couple projects in my undergrad. So my first kind of embedded systems class where they were teaching us um, the Verilog to begin with. My college, like I guess every kind of university or college, your embedded course either teaches you Verilog or Vhdl, and mine happened to be Verilog.
Mm.
We had to do a couple labs, one in ISE and then one with LabVIEW FPGA. So I'd used ISE a little bit, but really I just got thrown into it with Vivado. Um,
Mm.
so
Um, and so you were sort of writing this as well as for yourself, also to sort of help other people who were transitioning over.
yeah,
I also started out with sort of doing electronics as a blog that I was using as my own notes that I figured other people could use as well, taking photos along the way. And now, what is your main gig? How are you involved with Xilinx and specifically Spartan-7 these days?
so I am technically an ambassador / influencer. I use that very lightly. I think that's just some of the terminology, but I partner with Xilinx, and I've also partnered with Avnet, and several other Element 14 and Digilant and everybody, and to kind of when we bring when new products are brought to market, I'll do like getting started demos, unboxing demos. And with Xilinx specifically, they reached out to me in this push to update from the Spartan-6 to the Spartan-7/7 series FPGAs in general. And so I'm kind of working on highlighting some of the specific differences, some of the things you can gain, while also maybe kind of outlining some of the challenges that you might face when you're updating, because the easiest way, or I guess the easiest way I would say to overcome those is to at first be aware of them. So that's really kind of the initials. Like, we're really trying to convey, how do you use these? How do you take full advantage of them and make that information easy to find and have nice, clear, very detailed demos of that, rather than you having to read through, you as the user, read through 100-page, very dense technical manuals, because a lot of those technical manuals that are super dense and have all of that nitty-gritty info, they don't make a lot of sense if you don't have a clear picture of the overall workflow to begin with. So a lot of the recent projects that I've done on the SP701 to begin with are really focused on, like, how do you create a Vivado project? What button do I press? Like, what's the overall flow for a design? Like, create your block design, then create your wrapper to instantiate it in your design, and go through then the three main steps of an overall FPGA design, regardless of what tool you use, which is synthesis, place and route, and bitstream generation. So that's where, might have been a little rambly there, but that's where we're at with that.
No, that's cool. I was just writing down the 3 steps you said: synthesis, place and route, and I forget.
Bitstream generation. Yes.
Bitstream generation. And FPGA people get very particular. You're not downloading the bitstream to the board, are you? You're like doing something else. There's some other verb that they're very particular about. Or you are.
So you, when you generate the bitstream, it just basically takes your design and compiles it into that format that the actual hardware is going to read. And actually, if you're not familiar with FPGAs, you could almost call them a form of volatile memory, because the actual programmable logic, once you remove power, all of that memory of how the circuit's configured is gone. So the bitstream is stored somewhere in non-volatile memory. It's typically like QPI flash that's connected to the chip, and that bitstream is what, on every single power up, is what configures all of the gates into your specific design on the FPGA every time. So you're programming that bitstream onto that non-volatile memory, the QPSI flash. So, and typically and Xilinx also has a lot of tools. Specifically, that's one of the benefits of upgrading to the Spartan-7 and the 7 series, is that there is some encryption available, actually, to particularly prevent someone from downloading your bitstream off of the QPSI flash, and protect your design for whatever reason you might want it protected. So
that's really cool. Thank you for giving me that impromptu explanation. I've done FPGA stuff once before, and it was really fun, but I think it's a whole other way of thinking from a lot of this, like, uploading, downloading, programming, writing code kind of thing.
Well, even how you write the code is extremely different. My best friend's actually a software engineer, and we have conversations all the time, and it's really interesting to see the difference about how her and I approach things, because she works with object-oriented code, and so her mind thinks in terms of objects and how to handle those objects, whereas I like to say that I think in terms of every clock cycle, because with a hardware description language such as Vhdl and Verilog, you can only do, you're working on operations at one clock cycle at a time, and you're at that very low level, and things like loops and stuff are not, they just, well, there's a whole lot you can't do, because it is a very low level language at the end of the day.
I love it. And I can tell also, like, your descriptions of these things are so amazing and clear. It's amazing that I'm so glad that you've started writing these tutorials about this type of thing. Speaking of which, you do have multiple tutorials. Well, you have a ton of things on Hackster, but including getting started with SP701 in Vivado, getting started with lwIP, and we'll talk about all these things. And coming up, everyone stay tuned for a live demo, which, as live demos always go, there's there may be something, but we'll see. Yeah, why don't you tell us a little bit about the SP701 that you're working with?
So the SP701 is a Spartan-7 based FPGA development board, and maybe I want to give a quick top level view of whenever you are looking to create an FPGA design and you first choose your FPGA chip, I highly recommend picking a development board. Basically, any FPGA chip out there, and this is not unique to Xilinx. This is any manufacturer is going to create a development board with that particular FPGA chip on it. And typically those development boards will have just about every single peripheral on them that the chip is capable of supporting, just so that you can suss out your design, determine what peripherals you're going to need. And the point of that development board is so you can get your design up and going. And so when you jump into your own PCB layout or your own board spin of an FPGA, you've already proven the hardware and you've got the firmware to go with it. So the SP701 is that for the Spartan-7, and so it's got your 2 Ethernet transceivers on it. I gotta look down at it. I'm cheating over here. You've got your 6 PMOD connectors, which PMOD connectors are really great for some of your lower speed, lower pin count peripherals. Here, if you can see it there in your picture, there's on the left side of the board in the picture, that really dense.
Let's see if we can get it bigger. There we go.
Yeah. So the black connector that's long and it looks like it has a ton of pins on it, that's what's called an FMC or mezzanine connector. And those are intended for, that's kind of like, you know how a Raspberry Pi has hats that go with it? Yeah. This is kind of the equivalent for an FPGA, I would say. And it's meant for high pin count, high speed. Typically, you'll see a lot of like transceiver, like SDR design type with this particular connector on it. So you can kind of think of that as your shield or hat connector for your FPGA. So if, you can look out for those on your FPGA development boards. I highly recommend those. I use those a lot.
96 boards does a bunch of those, right?
Yes. And then, of course, you've got your HDMI out, which is typically, if I'm going to run an embedded Linux image on one of my FPGAs, I'll typically look for a dev board with an HDMI port on it so I can create a desktop image and actually just plug it into my monitor directly. And then the SP701's also got your standard push buttons and LEDs and other indicators that you see on pretty much every FPGA dev board you have.
All this stuff along the right side here.
Yeah.
Good stuff. And you've got some JTAG for debugging, a power switch.
And then you've also always love the power switch.
I love the power switch.
The power switch, you've got your MIPI and CSI, DSI camera connectors, which bonus, the Xilinx just made the camera IP, the IP block that controls those connectors free of charge. It's now included in the free license. It used to be, prior to 2021, you had to pay extra for that license, but now it's included in the regular free license. So Xilinx has been really good about expanding their what's included in their free license for Vivado. So you can download Vivado and get a really good solid design and have access to a large vast majority of the IP out of the box without spending any extra on licensing.
That's awesome. Yeah, let's hear a little bit more about the changes in Vivado. From what I understand, they've sort of rebuilt it sort of from the ground up and adding a bunch of new features and modernizing a lot of stuff.
It is very, very different. And kind of the main thing I typically hear, there's 2 main things that I always hear from people that are in ISE and maybe have just kind of looked at Vivado and aren't totally sure about it, is the switch from the schematic view, the schematic design flow, to the block design. And they're both kind of like more kind of block GUI type design. And because in Vivado with your block design, you create, if you don't, it's an optional thing, you can just do pure HDL designs in both. But in Vivado, you have a lot of that canned IP available in the block design, and you can just choose blocks, like actual blocks that you plop into the design, and connect it from there. And on top, and the second main difference is the introduction of the Axi interface, AXI. I'm trying to remember exactly what that stands for. I just wrote it down. But the Axi interface was, it's a standard introduced by ARM back in like 2003. And because Xilinx was once Xilinx introduced things like system on chips and system on modules that had a physical ARM processor embedded in the programmable logic, Xilinx saw the need to create some sort of standard interface to talk to the ARM chip and make that in a lower point of entry for complexity wise. So that Axi interface, all of their IP has that Axi wrapper wrapped around it. And as you kind of plop things into the block design and you plop that the instantiation of that ARM processor, the block design has this awesome connection automation feature, which will automatically go through and determine all the best timing and routing and clock fan out for you to kind of help you mitigate some of those maybe clock timing issues. And whereas with ISE, it was totally up to you to define all your interfaces, hand connect everything, hand code all of your HDL to have the right interfaces to everything. And so while it is going to be a certain amount of work and a certain change to then take all of your custom ISP or IP and wrap it with this Axi wrapper, another thing that another feature that Vivado has is it has a tool for creating those Axi wrappers for you, and it creates a lot of it generates a lot of the default code for you. So instead of having to write it all from scratch, you're just kind of modifying it to fit with your code specifically. And I actually have several tutorials on that as well, talking through those, because there's 3 different types of Axi interfaces that kind of fit different use cases. You have your full Axi standard interface, which is a very well-defined, arguably complex, but in a necessary way. It's a handshake. It's a series of handshaking signals. But then there's an Axi 4 Lite version of that, which is just, I think, just 4 handshaking signals, and that's really great for if you have an IP or you have something in your custom RTL that all you need to do is read and write to some control and data registers. Axi Lite is perfect for that. And then the third type of Axi interface is Axi Stream, which is like if you're doing something like a filter or a video stream where you have a constant stream of data with known packet boundaries. Axi Stream adds a couple extra signals of like T-last, and so that you can just you can keep that data flowing easily and just look for those little flags of like, okay, here's the last boundary of this packet. And so it's really great for, like I said, like for filters or video streams.
Rad. So it sounds like, well, maybe we'll start seeing some weird filters on your videos soon. But also, it seems like it might be a little bit of extra work if you already have a bunch of IP, but if you're starting from scratch, maybe Axi will make it a little bit easier for you to get started and not need to have such an intimate knowledge of the ARM side of things as well as the FPGA side of things.
Yeah, that's what the Vivado block design, if you're totally new to all of it, I would highly recommend starting with the Vivado block design flow and using some of the canned IP and really letting the connection automation feature in Vivado connect things for you and kind of see how it prefers to, or how it tries to do things, because it is configured to do everything based upon the best timing and routing for whatever target chip you have set for the project. So if you kind of make some of those example designs or just kind of throw things in there and see how the connection automation feature is behaving, you can then kind of get a frame of reference to apply to your own custom IP.
Cool. I'd love to get in on your sweet looking live demos here, but before we do that, it's worth mentioning real quick that we had a contest with Xilinx last year around a different board, the Kria KB260, and then also there's this other one that you've worked with yourself, the Arty Z7, which is another one that I believe runs on the Spartan-7 chip. Is that right?
The Z7 is actually a Zinc 7000, which is another chip in the 7 series family. So the Spartan-7,
right, yes.
if you're upgrading from the Spartan-6, it's not necessarily that you go straight to a Spartan-7. You may have a better fit with a different FPGA in the 7 series family. So you have, for instance, you have the Zinc 7000, you have the Kria SOM, you have the Arctic 7 and the Spartan 7, and depending on your design needs, so if you want or need that physical ARM processor embedded into the programmable logic, you're going to want to look at the Zinc 7000 or one of the Zinc UltraScale MPSoC chips, or the Kria SOM, which the Kria has more of that embedded vision hardware built into it. And then if you don't need the physical ARM processor and you're just going to go with the soft processor, the soft core processor, which just means it's a processor written in HDL instantiated in the programmable logic, you can go with the Arctics or the Spartan 7, or I think there's a Vertex 7. Oh, I can't remember. But the really the main difference that I remember off the top of my head between the Arctics and the Spartan 7 is if you need the GTP transceivers. That is something that is only in the Arctics, not in the Spartan now. There were GTP transceivers in the Spartan 6, but they're not in the Spartan 7. However, both the Arctics and the Arctic 7 and the Spartan 7 are both really great low power consumption, low cost FPGA chips. If I'm on a tight budget and I'm on a tight power budget, the Arctics and the Spartan 7 are the first two chips that I go for.
Woo, yeah. And you mentioned this in your getting started with SP701 and Vivado, that also this SP701 is one of the most ideal FPGAs available in Xilinx's lineup for its performance per watt's efficiency. There's a lot of emphasis on sort of low power, really efficient technology coming through here.
So I did a little experiment actually, and I should probably do a write-up on this, but to give you an idea of the power savings cost, so I had an Arctic 7 based design that the only thing I put in it was I instantiated Xilinx's soft processor, the Microblaze, and I created a whole bit stream. And what's the other really awesome thing about Vivado is you get your detailed timing report of exactly the timing of the timing of the entire design, but you also get this really awesome power consumption report, and as well as like it gives you an idea of the average power draw of your entire design. And so I did this for an Arctics based FPGA and only had the Microblaze in there, and then I created a separate project that was targeting one of the Zinc. It was actually targeting the Zinc Berry. So it was targeting one of the Zinc 7000 chips that have that physical ARM processor in there. And the only thing I instantiated in the design was the ARM processor. And just comparing the two processors in there, the Zinc 7000 chip on average drew about 1 watt worth of power, while the Microblaze and the Arctics chip drew less than a quarter watt.
Dang,
0.25.
nice.
So that gives you an idea of how you can like take your design constraints and then apply them to your chip choice.
That's so cool. I love it. Love everything low power. I'm so glad that you're explaining this stuff so well. And I feel like there's such a huge variety of there's such a huge variety of tools and options available, software tools, hardware tools, different types of Xilinx chips, different combinations of things that you can throw in, and you do an amazing you're just really good at breaking it down and making it legible to people who aren't necessarily experts in this field. I love it. On that note, would you like to give us your live demo now? I'd love to see that.
Sure. I can share my screen real quick. then I'm gonna. Okay, can you see my Vitis window here?
We can.
Okay. And I did see a question in the chat that I do want to address about kind of the Vivado, Vitis, and then OS.
Yeah, I wanted to bring that
I'll
up
get
later.
to that. Yes. So Vivado is your main tool here, and just to kind of give you a visual reference, this is the block design that we're talking about in Vivado. So you can see like you just have your blocks that you're dropping in here. And actually instantiating everything. And here is our soft processor, the microblaze. So this is that actual processor core that's dropped in here. And underneath the hood here is just the functions of a CPU basically in RTL. And then I'd like to point out, so my demo is going to focus on our LEDs. We've got some LEDs available on the board here. So you notice we've got our output pin with the 8 LEDs, and then we've just got a little Axi wrapped GPIO driver here. So you can kind of see how that gets connected in the block design. And so through this Axi interface, you've got a big interconnect here that you have all of your Axi points coming to, and that's just kind of multiplexed back into a single point of reference into the microblaze here. So you do all of your hardware design here in Vivado, and then to write the software that's going to run on our microblaze or Zinc 7000 if we were using a Zinc chip. Vitis is the software IDE side of things, and you can write in either C or C++, but you do need to keep in mind that it is the embedded version, not the full-fledged object-oriented that you're probably used to if you were writing in, say, Visual Studio, targeting a full-blown regular CPU, Intel-based CPU or something like that. And what's really awesome about Vitis as well is it's got a lot of canned projects, one of which being this a lightweight IP. So that I can come, what I did was I came in and I used the canned lightweight IP app or application, and I just added some of my own commands in it and then wrote my own code to control the LEDs, just turn them off, turn them on when the proper string is received. And since the lightweight IP works on sockets, I then was able to create this Python script over here that just opens up that socket. It's an Echo server that's running on the SP701. And then I just wrote the corresponding Echo client here in this Python script. It's going to run from my host computer. And my SP701 is hooked up to my router, which DHCP is taking care of, that's built into the lwIP app, has taken care of assigning an IP. And so I have a network, it's on my local area network now. So I'm going to run debug as and launch this on hardware so we can see it in action here. And then we've got our serial, because Vitis also has a serial terminal built into it. So if you wanted to use your favorite external one like Paraterm or Putty, you definitely can, but you don't have to. It's already built in right here. So I'm going to go ahead and let this run. I did have the choice to just step through this one line at a time like a typical debugger. And you can see I've got my Echo server started here at port 7, and it tells me my board IP. And you can see I've got that set here in my Echo client script. So I'm going to come over here and just, I should probably move you guys down so you can see
I'm gonna try and
our board here. We've got some
LEDs.
You can see where I can't see you guys, so I'll try. We've got our LEDs, so let's go ahead and run. And you can see it.
Oh, I see them going. They're very small.
We just cycle through. Yeah. So as you can see, you've got, oh, that's Inception there. There we go. See if I can get that back up there easily. And there we go.
Cameras and screens, always a challenge. That was awesome. Thank you for showing us. So it was receiving the messages and then like using those to control the LEDs, and it saw them.
Yes. Yes. So
Over
each
your
individual
location.
string that you saw pass through, it was saying that string in the lwIP app is correlated to the specific LED number. So as you would receive that string, and I wrote up that entire project here. So literally what you just saw, all of the source material is in this particular project on my Hackster profile.
Awesome.
So you kind of go through and recreate this.
You can see all the in-depth stuff. Ooh, I love this photo. Showing you a direct correlation between the hardware and the bits. Ah, so
Yes.
good. And can you tell us a little bit more about lightweight IP or lwIP? You've got a little bit more about that in this other project.
Yeah, so lightweight IP is a lightweight TCP/IP stack. I think the last time I clocked it, it's definitely for it's not for like video streaming or anything like that. It's something for a little bit on the simpler side. I think the last time I clocked it, it was around 10 to 100 megabit per second. So if you need something crazy with like gigabit streams, you would definitely want to switch to a full-blown embedded Linux image with that full TCP/IP stack. But that, like I said, it's just a lightweight TCP/IP stack that is ultimately an echo server running on a designated port on your FPGA.
Super cool. Let's get to some of those questions. So first up, the
Yeah.
one that you mentioned before from Sterling Hammond. Yeah, really appreciate the tutorials on Hackster, but often one version difference in the tools, Vivado/Vitis, causes the tutorial to fail at some point. Outside of installing multiple versions of Vivado, could anything else be done to make them more user-friendly?
So this is kind of the whole point of my blog is unfortunately, with how complex and intense of a tool set they are, and then also the fact that you're typically running this on something like a Linux host machine, and there's all the different versions and different version drivers of the OS itself that it's running on that kind of stems from a lot of that, or is what a lot of that stems from. So personally, that's why a lot of my really popular tutorials, I will make a new one every single time a new version of Vivado/Vitis comes out. And I do recommend, there's kind of a different balance with when you decide to update with Vivado and Vitis. I typically am a little bit more careful about upgrading OS. I think if you're a Linux user, you don't want to upgrade to the latest version immediately, like because I just recently updated to Ubuntu 20. I'd been on 18.04 up until very recently. It wasn't until kind of some of the Creo robotics stuff, which I'm gonna cover next week. Just because that didn't have anything for the older version. But one thing I started doing was definitely look for tutorials in your specific version. And then unfortunately, you do kind of have to start to be aware and get kind of a sense for what are the main differences between some of the different versions of Vivado. And then determining if it's a difference in because it could also be a difference in features of your OS. I kind of started mitigating that because, yeah, you do get to the point that your only option is to have multiple versions of Vivado/Vitis installed. I'm a huge fan of VMs. I would highly, highly recommend learning how to set up and use virtual machines. And I actually found some really awesome external hard drives, which let me grab some here. And what I do is I have, you can see,
Wow.
I have different hard drives
Oh my
that I
gosh.
have different OSs installed. And so I'm not consuming up. These are only about $100 to $120, depending on the size you buy, these little SanDisk solid states, and they're USB-C. So I'll install multiple versions of Vivado on these guys. And then also I have one of these is my Ubuntu 20 VM, and one of them is my Windows 10 VM. So I highly recommend using VMs to make, if you get to a point that you're like, hey, I just can't get this to work in this version, and I can't find a tutorial in my particular version, I recommend throwing together a VM, which I do cover those, that setup as well, how to set up your VM. Mine are all in Parallels, but I know there's tons of good tutorials out there for all the other stuff like VMbox and, VirtualBox and VMware, or can't remember, but yes.
Yeah. And all these other ones, DigitalOcean, whatever. Oh,
Yes.
That for me is one of the biggest pro tips to come out of this. Wow, I'm so glad you asked that, Sterling. Just seeing you with these like, you know, a fanned hand like hard drives with different OSs. That is so pro. I love that. Wow. Yeah.
And I do know that's not necessarily the most satisfying, quickly packaged answer, but to some extent, FPGA design there is a certain level of complexity that you are going to take on in FPGA design, and unfortunately, the version matching of everything is kind of one of them.
Yeah. We have another question, kind of jumping to a different topic here. Alwa Jasmati says, does Kriya robotics stack? So the Xilinx Kriya, there's the KV260 and so on. But the robotics stack support robots localization, and can it be applied to old Xilinx versions kits? So you just mentioned that you have some stuff coming up with this. Tell us about that.
Yes. And I'm actually still fairly new to the Kriya robotics stack myself. I am not totally sure about the localization. I do know right now KRS is still technically in its beta release, so I don't think that it's impossible to hand configure everything to apply it to an older, I assume you mean older hardware kit. I know right now it's really only support, like as far as like software versions, I tried to compile KRS in Ubuntu 18 and 18.04, and that just was a no-go. So as far as I'm aware, KRS, because it's still in its beta version, you can really only compile it on a host machine running Ubuntu 20 at the moment. And then also it only supports Petalinux 2020.2.2 and Petalinux 2021.2. So I will say, I think that will expand once it kind of gets out of its beta release, but KRS is very, very new. So there is a little bit of constraint there.
Yeah, it looks like it builds on ROS 2, which itself hasn't been around for that long. It's still pretty new.
Which I think that's some of the constraint, because if you're looking at the different ROS versions, and I do have a tutorial on installing the different versions, like the alpha version of KRS versus the beta version. Ooh. And those do use different versions of ROS, and kind of if you kind of go down the rabbit hole of prepping your Linux environment with all of the proper dependencies for that, and they're very different between, depending on which version of ROS you're installing, which ultimately dictates which version of KRS. And it's so new right now that there's not even an actual Linux repository. You have to build your own, write your own repository script essentially right now still with it, which is all in my tutorial there. And it's also documented well on Xilinx's Github.io site. So yeah.
Nice. We have another question from Ogus. FPGAs are cool gadgets. I wish they could become more affordable. Now, this is something that we often see. People are often working with these in more industrial environments where they're more working with a company. But, there are a lot of individuals who want to get started. And for them, what would you recommend is sort of a lower cost way to get started with FPGAs?
Yeah. I would recommend looking for, like in the Xilinx series, I would highly recommend looking for the RTX-based or chips, specifically on maybe some of the more hobby-geared sites like Avnet and Digilent. They have some more affordable, and I know there's also student discounts that are offered there, which is how I initially bought some of my first FPGA boards, like the pink board. But I do highly I think some of the more affordable one, I would say the Arty board. But also if you're new, if you're coming from the perspective of PCB layout, and you want very, very low cost. While I absolutely love Xilinx, I do also like the lattice chips, and so like the tiny FPGA. I think the lattice chips are a little bit easier to get started with for if you're looking at PCB layout, just because you can get a lot smaller chips with a lower pin count. And then as well as like your programming, having the actual chip with your Xilinx license, the lower level, I think the lattice chips are a little bit easier on that perspective. So that's where I would steer people from that perspective.
Yeah, I gotta point out for people who want to get started in a low cost, affordable kind of way, we often have these challenges and contests like we ran with Xilinx last year, the Adaptive Computing Challenge. You can submit ideas for projects and then you'll be able to be eligible to get hardware for free. We've also...
And also, Xilinx also has an emulator, the QEMU, which you can emulate just about any board. And there's also tutorials on how to set up that. So you can emulate any of the boards as well.
Cool. Yeah. Just pulling that up here. QEMU. Cool. Thank you. Another question from Aula. I love how engaged this audience is. This is so cool. I have a set of sensors, GPS IMU mini LiDAR, and a robot platform that looks like the one on the shelves behind you. Eagle-eyed watchers here. And Aula's done a bunch of cool projects as well. Which Xilinx board would you recommend working on to locate the robot?
So that would really depend on the number of I/O you need, because one of the biggest constraints that you would want to start with when you're picking out an FPGA development board is the number of I/O you need. That's typically my starting point, or one of my starting points. So I think if you really, I'm remembering everything. So if you need a ton of high-speed pin counts, I would look for one of the FMC-enabled ones. If you kind of need mid-range, I like I said, the RDZ7 or the RDA7 boards. The only difference between the RDZ7 and the A7 is the Z7 has a Zinc chip on it with that ARM processor within it, whereas the A7 is the Arctic 7 chip. And it has an actual Arduino pinout, I think it was an Arduino Mega pinout header on it. So I know if you're doing a lot of robotics,
many pins.
you probably have one of those shields for the motors that is maybe for an Arduino that you could then plop right on top of there. And let's see, what else? It's kind of like when somebody asks you what your favorite music is, you suddenly can't remember. Everyone's like, okay, what else? If you're doing a lot of like robotics, like AI vision stuff, if you can find one, I would recommend the Korea robotics version, the KR260, which is coming out soon. Because that's going to have a lot of the built-in hardware into the SOM for a lot of that image processing, and then have a USB camera, or I can't remember if it has a MIPI connector on it, but that'll save you some of your pin count.
Oh yeah, and I misspoke earlier. I said KV260, which is the Vision AI starter kit, and as Shakizat here points out, the robotics one is the KR260, like you just mentioned.
I keep switching the letters as well.
Yeah. So yeah, what do you think are the main differences between those two, the robotics starter kit and the Vision AI starter kit, and what would you suggest to buy?
So the main difference between the KR260 and the KV260, I guess I should back. So they both have the Korea SOM, which is a system on module, and a system on module style FPGA is where the actual FPGA and all of its bare minimum to survive circuitry is located on a separate little PCB that then connects to a baseboard or a carrier board. So the baseboard is the actual has the FPGA plus its power supply and QPSI flash, and then that's connected to a carrier board. And because they're both called Korea, which is the actual little baseboard with the Korea on it, and then the KR and the KV260 refers to the carrier board that goes on. So the difference between it is that what peripherals are available on your baseboard there. So the KV260 is geared, like its peripherals are geared a little bit more towards actual like vision. I know you've got that MIPI connector, the camera connector, your USB 3.0 ports for connecting webcams and visualizing, and then the KR260, which actually, if you don't mind pulling, I think it's on Xilinx's page. If you don't mind pulling that up, then we can kind of look.
Yeah.
That's really, if you're looking at what peripherals are available, if you pull up the KV260 and the KR260 pages, you'll see which peripherals are different there. And depending on if you're wanting to do more robotics types things, and you need to have an idea of like what sensors, and if you're using motors or cameras, know what you need for your project, and then choose which carrier board, the KR260 or the KV260, based upon those needs.
So yeah, here's the KR260, and then we have the KV260. Yeah. I remember being at they have very different fan cover or fan. They have a special name for that. It's like a fan block or something. Colors, and someone at the Embedded Vision Summit was upset about that I had the wrong color last week. But they're very stylish. In case you care about that. But here are those product pages, and I'll try to put those in the description later on. For now, you can go look them up yourself. Yeah, the KV260, we've done a bunch of stuff about that on Hackster. The KR260, a little bit newer. We're going to be...
you do have more broken out I/O on the KR260, which on the... so, like, you might have a little bit of trouble getting all of your motors and everything connected to the KV260, because the only user I/O you have is that singular PMOD connector, whereas it looks like you've got a whole header worth of I/O. Yeah.
Up at the top right there, that's just one PMOD, versus over here you've got more of a Raspberry Pi style breakout here.
Yeah.
Cool. And that goes back to
exactly. Looks like you got 4 PMOD there too.
Oh yeah, right at the top. And it goes back to what you were saying about in response to the questions earlier about robotics, and basically just choosing what has the I/O for your application in terms of when you're trying to control hardware. I do want to take us back, actually. She asked about your robot back there, but it's sitting next to this Ouija board, which is another... I loved when you published this project a couple of years ago for Halloween, and I love it as well because I made this like ESP8266 programmer, and I feel like someday we've got to get these two projects together in the same place. I don't know how it would work, but yeah, tell us about this project. It's not necessarily totally related, but it is as well. It's an FPGA.
Yes, when I saw that I had this project. This project was in the works for a very long time, and it needs a 2.0 because it did kind of. I hit some project obstacles and learned a lot about project planning with this. Because I don't have it fully specced out the way I want it to. But long story short, I just got through the Ultra 96. I stole the web server on the Ultra 96, and I installed it on the Mini Z here, and basically just created a single blank page that a user, if you're connected to the same network connection, or if you set up port forwarding, anybody anywhere can connect to this web page and type in a string to send to the FPGA underneath here. And what was going on is I mapped out exactly where in space each of the letters were, and those were actually all 3D printer parts that are dragging, like there's an electromagnet that the FPGA turns on, and I had magnets in the feet of the planchette. And so and then I have an Arduino there, and because Fritzing didn't have an FPGA. So but really, essentially the FPGA had an algorithm that knew when to turn on which electromagnet, and then when to pull it back and forth across the and I didn't get enough pictures before I like sealed everything up, but essentially like everything was mapped out such it knew how much to turn those motors and drag the planchette back and forth to, and I think I only got one row of letters working. And based upon that string, it would just pull the planchette back and forth and make it look like it was moving on its own. So to actually have a true FPGA spirit talking to you.
You've got so many other cool projects on here, and I wish we could go through all of them, but we are nearing the end of our time. Oh, but everyone, go check out, it's linked below Whitney's profile on Hackster. Just go dig through there. There's got 80 projects on here, and a ton of followers. There is a question from Jess that I was trying to get around to this one. What kinds of applications are other people building with the SP701 dev board? Because you've got all these amazing tutorials.
So a lot of with the SP701, a lot of them are focused on either, I've seen a lot of really cool like pure RTL designs where people are trying to bring in some of their own custom designs, as well as because it has that FMC connector. I've seen some people playing with some of the analog devices. The analog devices makes a lot of transceiver chips for SDRs, and I've seen people trying to port because the SP701 is not a default design from analog devices, so they're taking that transceiver chip, connecting it to the FMC, and trying to like maybe start some Spartan-7 based SDR designs. So I think that's probably some of the coolest stuff. And then a lot of stuff taking it, since you've got your 2 gigabit Ethernet on here, or not gigabit Ethernet, but you've got your 2 Ethernet connections on here. So I've seen some dual Ethernet with 2 different microblazes, both running that lwIP application. So
that's so. Wait, what do people do with that? I've never even thought about having 2 Ethernet connections on a single board and what that might enable.
That's kind of the nice thing about an FPGA design is if you have those 2 separate microblazes on there, you can instantiate separate local memory for them and basically just have them both running there. Where it gets kind of complex is the bit stream that programs on, and there's some stuff you have to do with the linker script and Vitis to kind of, but once you get past that, they're basically both running independently. So you can have 2 independent soft processors running in the Spartan FPGA at once, and just maybe doing, if you have 2 separate tasks that need to be done and you only have 1 FPGA, there you go.
That's so interesting. Huh. Another question. So you have a connection to Vhdl as well. We're curious if you know about other Spartan-7 stuff that might be on the horizon. And the answer can be no, but like maybe yes?
I don't currently know of anything. I hope I would be in the loop very soon, if there is. But I'm not sure. There's some other cool stuff coming up with Vhdl that I'm not sure how much I can say with those, but definitely between AVNet, Vhdl, and Element 14, those are all kind of my 3 main resources that I always recommend everybody to keep an eye on, as well as Hackster, which we're here.
Oh yeah. And we will have a deep dive article coming up later in the month as well on the transition to Spartan-7 that's much more sort of in-depth. So we don't have to cover everything right now, but stay tuned.
Where my rambliness is curated and a little bit better edited.
Yeah, so stay tuned for that on Hackster News and also on your Twitter, which we'll go back by. One final question. I'm consulting since my knowledge is so weak about FPGAs. Well, that's why we're here. Can FPGAs be programmed via Matlab instead of using Vhdl or Verilog? Matlab? I hadn't thought about that.
The short answer is yes. There is actually through Simulink, there is a toolbox specifically for Zinc that you can use and upload designs. That, however, is a very, very complicated kind of thing to get started with. I would recommend maybe kind of getting more familiar with how to program it classically with Vivado and Vitis and kind of get to there. And then because there's also different toolboxes such as HDL coder and embedded coder available in Matlab to convert either high-level C code or your actual Matlab script into HDL for you. But that whole workflow is something that is more on the complex side. So yes, it's definitely possible, but give yourself plenty of time to get that figured out, I would say.
Mm, legit. And since there are, you know, free versions of Vivado and stuff available, accessible to people, like maybe that's a better way to go. We're
You
about at
can
time.
get
Oh.
you yeah, you can, so just as a quick, like, you can sign up for a 30-day trial of
Mm,
Matlab. So that for that.
cool. Yeah. And of course, so there's Vivado, you can get the free standard edition, and there's licensed options as well. We've been talking a lot about the Spartan-7 SP701 FPGA evaluation kit. You can check out Whitney's amazing tutorials on these, getting started with the SP701, sort of a basic one, then lwIP, and this demo that you showed us with controlling LEDs over the LAN using lwIP, sort of going step by step. You've also got some other useful stuff that we pulled up really quickly. Um, of course, follow Whitney on Hackster. Oh my gosh! And on Twitter as well at Nitronics. I wish that we'd had more time to talk about your blog, but maybe we'll have to get you on again at some other point, and we'll talk about
Yeah.
your
And I also need to update my website. I haven't had
same.
time in a
It's been years.
while.
That's how it goes. Thank you so much for sitting down with us and going through helping us tease apart this migration and all this interesting stuff that's going on with the SP701. Yeah, thanks.
Well, thank you for having me. It's a huge honor now. So I've watched this for a really
Yeah.
long time, so it's really cool to be on here.
We'll have you on again more to talk about your more of the stuff that you do yourself. Thank you everyone for joining and posting such interesting questions. And I feel like I learned a lot as well from you asking your questions. So thanks a lot. And we'll see you soon.
Bye.